we are going to solve equations of the form tan and theta plus alpha equals b. Look at exercise 3. We are required to solve the following equations for theta in the intervals indicated. Give your answers in radians. We are going to solve part C. Tan 2 theta plus pi over 4 equals 1, where theta is between 0 and 2 pi. First, we need to define the variable x. So let x equals 2 theta plus pi over 4, where theta is between 0 and 2 pi. This implies that tan x is equal to 1. Now we need to change the boundaries of the interval. As we said, theta is between 0 and 2 pi. First, we multiply by 2 in order to get 2 theta is greater than 0 and less than 4 pi. Then we need to add pi over 4 in order to get the following. Pi over 4 less than or equal to 2 theta plus pi over 4 less than or equal to 17 pi over 4. That means x as an angle is greater than or equal to pi over 4 and less than or equal to 17 pi over 4. Now we define the intervals for x and we have the equation. Okay, we can use the calculator. Using the calculator, be careful that the unit is on radian and not degrees. X is tan minus 1 for the value 1. Now on the calculator, shift tan 1 equals to pi over 4. We accept it because in the interval it is greater than or equal to pi over 4. Okay, now we are going to move to the quadrant plane. Where is the tan positive? Tan is positive in the first quadrant and in the third quadrant. We will draw the pi over 4 like this. This angle is pi over 4 and this angle is pi over 4. The values for x are the following. X equals to pi over 4. For the second one, pi over 4 plus pi. So that means pi plus pi over 4 is 5 pi over 4. These are our two values. However, the x is still far away from 17 pi over 4. That means there are more angles or revolutions that can express x while being in this interval. To find these angles, we add the period of tan. The period of tan is 180 degrees or pi. We are going to start with the second angle because if you add pi on the first angle, then it will result in the second angle. That is why we start from the second. 5 pi over 4 plus pi is equal to 9 pi over 4. 9 pi over 4 plus pi is 13 pi over 4. These are very simple calculations. 5 pi over 4 plus pi, which is 4 pi over pi. In other words, we are adding 4 pi over 4. So 13 pi over 4 plus 4 pi over 4 is 17 pi over 4. Now we stop because we reached the maximum value in the interval and these are the values of x. Now we need to find the values of theta. Now we go back to the initial form of the equation. X is 2 theta plus pi over 4. 2 theta is x minus pi over 4. Theta is x minus pi over 4 all divided by 2. When x is equal to pi over 4, it implies that theta is equal to, instead of x, we put pi over 4 minus pi over 4 all divided by 2. 0 over 2 is 0. So the first value of theta is 0. Now, when x is equal to 5 pi over 4, implies theta is 5 pi over 4, which is the x, minus pi over 4, all divided by 2. 5 pi minus pi is 4 pi. So 4 pi over 4, all divided by 2. 4 divided by 4 is pi, so pi over 2. This is the second value for theta. And so on. You simply substitute the value of x to find theta. When x is 9 pi over 4, theta is pi. When x is 13 pi over 4, theta is 3 pi over 2. When x is 17 pi over 4, theta is 2 pi. Now let's look at the range of theta. It is from 0 to 2 pi. So these values are accepted.